Hello friends. So in our last videos we started talking about the big challenges in data science. While a project manager or data scientist starts working on a data science project, what are the different challenges they face, right? Or they might face. So let's go into each of these challenges and try to, explore the ideas behind these challenges. What are they? Why are they? Yeah. Good versus bad data. So while we start working on a big data science project, the first step is acquisition of the data. And while we are trying to acquire the data, there are different sampling methodologies we may, employ or deploy. So there are three different types of sampling methodologies. Like we have cluster sampling, we have stratified sampling, we have random sampling. So depending upon the methodology of sample, the depending upon the sampling methodology, whatever we are using, and also how uniformly we are using these sampling methodologies, the data can be as good or data can be as bad. On top of it, if you are not uniformly sampling the data from all the corners of different stratas, then your sample data may not be that good enough to give you the better results or better accuracy for your model. So sampling is one of the very important part while you are acquiring data from different sources, platforms, tools, or technologies. At the same time, when we have sampled the data, we need to look into the missing values. We also need to look into the outliers. What are the different multiple features? How many features are we using? So all these things actually attribute to categorize the data set as a good data or a bad data. So we need to take care of it. The second part is data preparation. We know that once we have acquired the data, the first step is we have talked to the client, we have talked to the business, and we understood that this is the problem set, this is the case study, this is the project on which we need to work. And the second step is acquisition of data that we talked about, where we are acquiring data and using different samples and treating the data. Now, the next step is data preparation. While we are preparing the data, 80% or 70% of the time of a data scientist goes into preparing the data. What does data preparation mean? It means cleaning the data. It means acquisition of the data, cleaning the data, data understanding, analyzing the data, visualizing the data. So all sorts of steps which you carry out to understand the data and bring the data to a situation, to a position where it is ready to be consumed by a model or an algorithm. So those steps where we actually bring the data to that position where it can be consumed directly by a model or algorithm. So all those steps which we carry out while cleaning the data, acquiring the data, outlier treatment, missing value treatment, everything comes under data preparation. Even the visualization of data and the basic analysis or descriptive analysis, whatever we do, so that comes under the data preparation. So it consumes around 70% to 80% of the time of a data scientist, and it's a huge time. you know. And at times, what happens is that an idea is conceived by the business user in the month of January. We started working on the month of February, and by the time we have completed our data preparation in say a few months, we got to know that the use case study, the case study or the project requirement has changed. Right? So it's very much important that we actually speed up the entire data preparation stuff. We can use new technologies like augmented analytics and auto feature engineering as well to speed up the entire data preparation. The next step is the next challenge is heterogeneous data sources. So they're different. So data. I mean, while we are acquiring the data, we understand that the data is coming from different tools. It is coming from different systems, applications, platforms. So the data is in the different format. One of the application or system or tool is giving me data back in the form of an XLS. One of the data source is giving me back the data in the form of PDF file or maybe images. So there can be different types of data as well as there are different sources of data, different CSV files, XLS files, or different tables or different databases it is getting it is attached to, and it can be in the different formats as well. Same customer ID is being used in a different way in one of the system, the same customer, and there are different methodology by which we are actually creating customer IDs in a different platform. So everything needs to be actually, everything is mismanaged, mismatched, and everything needs to be brought together at one place, which will be called single version of truth, or it will be called as a centralized platform where we have brought in together all the different types of data sourced from different on multiple data sources. So it's a huge task, and This is also a big challenge while we are executing a project. Very important part is data security and accessibility. We all understand the data is being created or being generated at a very massive speed, which we can even not realize or think. The amount of data which is getting generated at each every millisecond. So at the same time, we have got cloud data managements, like we have GCP, we have Amazon Web Services, we have Microsoft's Azure as well. So all these cloud data management systems are taking care of the huge data in terms of in terms of storing or in terms of providing security. But at the same time, while everything is getting digitized, we are going digital, everybody is using the digital platforms. We also need to realize that with the flow of huge massive amount of data into this world, there is also we are also prone to the cyber attacks and data hacks as well. So while the data is getting generated at a massive rate, we also need to be very stringent, and we also need to come up with more and more data governance and regulation standards, which will be more robust, which will be more strong, and which will be more efficient, and to combat cyber attacks and data hacks. So we need to have controls and governance checks in place, and more robust and more stringent governance and regulation standards. At the same time, while we are using any particular platform or any applications data, there are several rules, which is where there are several rules and data norms, company specific data norms, whose products we are using to get the data out of it, to scrape the data out of it, or maybe it is country specific data norms as well, which we need to adhere. Like if we are using a Twitter data set for sentiment analysis, then there are different rules and there are different questionnaire we need to fill in back, give it back to the Twitter company to help them, give us back the API in the developer account. So what are we doing? We are actually adhering to the company specific data norms. And these company specific data norms are based on the country specific data norms. Jumping into the solution right away. This is one of the biggest problem. While we have got a project, we have got a case study, we have got a problem statement from one of the business users, we jump into the solution right away, that this is the algorithm we are going to use, and this is the methodology, this is how we are going to do it. No. So you need to first understand the domain, you need to first understand the data, you need to understand first the business, how the business is flowing. In case you are having any issues, then you check with the SMEs, you go back to the business persons, business users, you check with the SMEs to understand the data lineage, data pipeline, data flow, and business as a whole at a very holistic level. Then only you start you analyzing the data, and then you can talk about the solutions. At the same time, what are the different algorithms or methodologies you can use. Inter-teams collaboration and management. At the same time, while we are working on a data science project, we also need to collaborate and manage different teams, because one of the team will be providing infra, because there will be huge infra which will be required while we are working on a humongous data sets. At the same time, the infra should be very robust and strong. The technology should be the technology which we want, that technology should be available. you know. So we need to liaise between the different teams, and that those teams should also understand our problems, that what we are facing, and there should be a cohesive collaboration and environment in order to succeed and give data science projects a success. uh, Data scientist knows all. This is one of the biggest myth which we are living right now. Data scientist is not a god. He's not somebody who knows each and everything. Like data scientist is somebody who should know probability, statistics, SQL, Tableau, Power BI, big data, Scala, everything. I mean, this is not possible at all. He should be able to know deep learning, machine learning. I mean, it is not possible at all. I mean, there should be separate teams for initial data engagement. There should be separate teams to liaise and facilitate between the technology and the infra team, or maybe the technology and the business team. There should be a separate team, or maybe the separate specialist uh, there to work on the just the EDA part, so that they can do their best in terms of cleaning the data and providing the good data and analysis and visualizations. There should be some specialist who should be best in terms of doing the modeling, that is understanding that this is the algorithm which fits in best, and giving us the best model in terms of accuracy and train and test model. So so a data scientist, one person cannot be the person for everything. There should be separate teams, specialists to work at different stages of the data science life cycle. Non-technical management is another important aspect where we face challenge while we are talking with the senior management or senior executives, because senior executives are talk about the business. They talk about the business, they understand the business, they understand the bottom line numbers, they understand the revenues, they don't understand the profits, right? And they are not somebody who is very technical. I mean, there are exceptions. I mean, somebody, so there should be enough knowledge for these management people, or we should be effective enough to communicate with the management in the language, or maybe we should be effective enough to talk with these management or executives in a language where we can help them explain them in a better way, because their knowledge is limited. And when we start talking about the hypothesis testing, p-test, z-test, or maybe you talk about the covariance or regressions, or svm support vector machines, they wouldn't be able to understand. They understand the metrics, they understand the accuracy, they understand the results, right? And that is why the non-technical management have unrealistic expectations. Like they expect everything can be done. But yes, everything can be done in terms of technology, but there are certain requirements. If we are able to meet those requirements in terms of time, in terms of cost, in terms of technology, in terms of platforms, there are so many things in terms of data what we want, in terms of skills which we are lacking within the company. So if each and every things are in place with the appropriate cost and time, then yes, we can meet the expectations. Everything is possible. But at the same time, there is unrealistic expectations which we need to be very we need to engage and communicate with the management in a very efficient way, and help them understand that this is the problem, and if we want to achieve this, we need to have these skills, cost, time, and so on. Accuracy checks and metrics. This is one of the important aspects. While we have started working on a data science project, there should be an agreed, well-defined KPIs and accuracy metrics, basis which we can at least test the model once the model is ready. Because if that is not there, then so the requirement should be agreed and signed off, and at the same time, the accuracy checks agreed, KPIs and accuracy metrics should also be ready, agreed, and and signed off, so that once the model is ready, we can just give them that this is the KPIs what we discussed earlier before the start of the project, and this is how the accuracy is being met by the model whatever we have produced and developed. I hope so. These are the certain big challenges in data science project while we start working on a data science project. I hope I have tried to cover each and everything. If you think that anything needs to be covered as a part of big challenges, please go on to the review section or comment section, and please let me know that this is also one of the additional big challenge what you see in a data science project as per your experience. Okay, thank you friends. See you again in the next video. Thank you.